can like record things. All right, so example one, we want the prime factorization of 24. So this is actually something you guys have probably already done, right? So when you have prime factorization, you're just breaking it up into a math fact with only prime numbers. So I think we did this in 5th grade where someone give me a math fact of 24 that is not 24 and 1. Xavier. 6 and 4. All right, now we can just go ahead and break these numbers up even more. Give me a math fact of 4 that is not 4 and 1. 2 and 2. 2 and 2. Right? We want the factors, not multiples. And then 6 breaks up into 3 and 2. So if I had the prime factorization of this, it would be 2 cubed times 3, because those are prime numbers. Or you could just go 2 times 2 times 2 times 3. Both of those are the prime factorization.
So do you keep on going down until you can't?
And exactly, until the only options are 2 in itself. So we just break it down until yeah, because we have 1, 2, 2, 2, 3, 2, and the 3. No, you want to go least to greatest. X, quit talking. What signs?
It's not 2 times 2 times.
Yeah, there's dots there. Let me just zoom in. There are dots. I just didn't draw them. There you go. Yeah. All right. So that is prime factorization. So when we factor things, we want to, in a way, break it down and extract prime numbers or math facts. It can be math facts as well. So, for example, 2, you're going to have an expression right here, and it says we want to factor the expression using the greatest common factor, or the GCF. So let me write this in red. Or blue. This is not on your note packet, but if I had an expression like this where I have x plus 8, you guys would know to use what property? Distributive, right? You would multiply both in, so you would get 2x plus 16. Well, if I take this fraction, what I can do is I notice that I can divide each term by 2, specifically the coefficient and the constant. So if you divide that by 2 and divide that by 2, you're just going to get x, and technically it's 1x, same thing. And you would get 16 divided by 2 is 8. And to show that we divided by 2 and we extracted a 2 out of each term, you would put the 2 on the outside. So we have the distributive property. And then for example 2, we have what's called factoring expressions, which is the exact opposite. It's the exact opposite of the distributive property. So what we want to do, I'll write that a little bigger actually. Yeah, I have to plug in the HDMI cord here. So if we look at this expression on the board.
Who's here, guys? What's the party?
Oh, the party. It's raining. Where's your party?
There we go. You don't need tardies on this thing. All right, so we have this expression right here, and what we want to do is we want to factor this expression. So our first step for factoring is you got to find a math fact that you can divide both terms by. So what can I divide 3x and 12 by? Let's go with y. You can divide both by 3. So I'm going to represent that with a fraction bar. Okay? So when I divide by 3, what is 3 divided by 3?
1.
That's just 1, so it's 1x. You could just put x if you'd like. What is 12 divided by 3?
4.
And is it going to be positive 4 or negative 4? Positive, because we're adding. And then, how do I represent that I just divided by 3? Well, I'm going to put parentheses and a 3 on the outside. Because it's not that we're trying to take away 3. We still want to keep the 3 there. So we have to represent that through multiplication, through parentheses on the outside. Yeah. So whatever you divide by, and let's think about this logically. The distributive property is what? It is basically what? It's just multiplication. So the opposite of the distributive property is factorization, which is just division. And we represent that by taking the 3 on the outside. So this is called simplifying expressions through factoring. Yes?
You never solve them, right? And also,
Yeah, because there's no equal sign. There's no equal sign, so you don't solve it. And the reason why it's called factoring is because you are taking a factor of both terms and you're dividing it. Yes, Voss?
Is this the GCF?
The greatest common factor, yeah. We'll talk about what I mean by GCF in a couple examples. So let's go to example 3.
Oh, and it's 1x first because x is a variable.
Yeah, you want the variable. So we have, so Foss had a really good point. He said something about the GCF, which is the greatest common factor. So we have this example right here, which is 4x plus 20. Now, here's why factorization requires the greatest common factor is, am I able to divide by 2?
Yeah.
Yes, but am I also able to divide by 4? Yes, which one's greater? 4. So you always want to divide by what is greater. So I'm going to go ahead and factor this by dividing by the math fact 4. When I divide both terms by the math fact 4, what do I get?
1 and
I'm going to get not just 1, it's going to be 1x
x
plus 5. And it's positive because we're adding. Yeah, and then we have to take our parentheses. Because we divided by 4, it's going to go on the outside, right? We want to represent we divided, we simplified, we're going to multiply it back in, right? And then if I go ahead and use the distributive property, if I distribute the 4 back in and go backwards, I'm going to get 4x plus 20, which is my original answer. So it's the same thing, we're just simplifying it. We're not changing the value. We're not making it larger or bigger. We're just showing it differently. So what I circle in blue is the right answer.
Can I just put x?
Yeah, you could just put x. You don't need 1x. All right, so example 4, I want you to try it on your own. Example 4. The deal with example 4 is that you could divide it by 2 and 5, and you got to figure out which one to do it by. So it's 10x minus 40. 10x minus 40. All right, so you could do it by 2, you could do it by 5, and you could also do it by 10. So you got to,
subtract, does that make it negative?
yeah, exactly. All
You
right.
keep the negative when you factor it.
Yes, you keep the negative, yes, because you're technically dividing negative 40.
Oh, and you don't solve it, so would it be like a negative 40 or is that?
It's negative 40, yeah, so you're dividing
plus
by negative 40.
Could you do
You could do plus negative 40
minus
or
40?
minus 40, yeah.
I just do my
Yes, Pax?
I'm done.
What'd you get? Or Pax walk me through what you got.
Okay, I see it. I did it by 10, so if you divide 10 by 10, you get 1.
There you go, so that turns into 1x.
1x. And then for the negative 40, divide that by 10, so you negative 4.
Negative 4 after you divide by 10.
Then it would be 1x plus negative 4.
Oh, I see what you did there.
Then you need parentheses and the 10 on the outside because it's divided by.
Yep. And then the 10 on the outside. So this is correct. You guys, pay attention. You guys could also just go minus 4.
Yeah, that's what I
It's the same thing. If you want to add a negative or if you want to subtract, that's fine. This is the correct answer. But if you put plus a negative, that would also be a correct answer.
got you.
It just, yeah, exactly. Remember, subtraction problems are just addition.
Whenever it was like a huge problem, I did that because it makes sense. I did it. It's like
The plus and negative or just minus?
the plus and negative.
Yeah.
Because like if you put plus after everything no matter what, and then it's positive.
Yeah. And in my mind, it's like adding debt. You know what I mean? All right. So number 5, I think you guys kind of got this one figured out. Number 5 is a little difficult. Not a little difficult, but we have something longer.
I know this is long done.
That's sad. Listen, come on.
Okay. So, could we factor right now?
No.
Well, why not?
Yes.
What could we divide all these terms by? We could divide by 2 everywhere, but what should be our first? Sophia, close the Chromebook. What'd you say? That is correct. Our first step should be combining like terms. So I'm gonna move things around, and I'm gonna move it around like this. So I'm gonna have 4x plus 2x. I'm gonna go ahead and put that in parentheses, and then I'm gonna do plus negative 10y minus 2y. And then I can't forget that minus 18, right? I'll put the minus 18 at the end, right? So I've just rearranged things so that I put the like terms together. And then I'm going to combine like terms. So what is 4x plus 2x? 6x. And then what is negative 10y minus 2y?
12y. Wait, 6x and then it's
Negative 10 minus 2 is not 12y.
Negative
Negative 12y. So we can add a negative 12y, or you could just subtract 12y, same thing. And then we got to remember the minus 18. And what I'm going to do is, instead of doing a plus, a minus, I'm just going to make it a subtraction sign. Now we can check it out. So if I just combine like terms, or excuse me, if I factored the first expression, I would divide by 2. But if I combine like terms, now what can I divide by?
3.
Higher than, yeah, we can divide by 6. We could do 3, we could do 2, we can do 6, but we always want to use the greatest common factor. All right, so if can I erase some of this?
Yeah.
Okay. So if I factor out the equation that I have on the bottom, what am I going to end up with? Someone raise their hand. What could you do? Josiah, what would I get?
Oh, wait, is this the answer?
Yeah. So what would the answer be?
Okay, so it'd be like 6 on the outside and then
6 on the outside, yep. In parentheses.
X
1x
negative 2y
plus negative 2y
minus 3.
minus 3. And that would be our answer. That would be our answer.
Really? Ross, it's actually very easy.
It just looks complicated.
This used to really bug me as a student. I couldn't do this as a kid, and I got to high school, and I was explained a different way, and I was like, oh, that's easy. But I wasn't the best student in 8th grade, so.
I know you were.
Ha.
Ross, did you get the?
Yeah, no, your mom didn't teach me bad. I just didn't listen.
Ross, what do you think?
I didn't need it.
Example 6 will get tickets. So, example 6 is kind of a challenge question here. So, example 6, you're going to have something that looks like this, where it's 14x squared plus 2x minus 2x squared plus 12 plus 6x. I'll give tickets to whoever can answer this question.
I have the whole
Ross,
I
are
have the
all
answer.
X's the same? Like you
No, they're not. So,
This is easy.
all x's are not the same. So, I want to point out, Josiah's a good question. What
The ones that are squared.
in blue, those are like terms. In red, those are like terms. And then obviously this one on the end it's just a
So
constant.
that way 6x are like terms.
Hey,
Yes.
I think I'll finish.
Why put your hand down?
I'm gonna wait till everybody, and you have to, if you want the tickets, you gotta walk me through it. Yeah.
Oh, no.
Hey, stop. Giselle, no. Giselle, you're not allowed to do that.
I'm saying
Ross,
2x, 6x. Yeah, that's right. We set it up. Keep going.
Ross, wait. How are those all like terms?
So what's in red are like terms. What's in blue are like terms, and the green is by
No
itself.
one could see.
the one with the
Here.
fancier X is
Ross.
it's just
That's green.
Ross.
Oh, green. Okay.
That's red.
I know that's red, but which one's green? Also, it's like that. Is that the
Are you
only-
colorblind?
Oh, that's easy.
Ross,
Christian McCaffrey's colorblind.
that's crazy, Ross.
Yeah, you can't see. You can't see. Hey, you can't see the color of his jersey.
I had no.
I'm better than him. Doesn't matter.
I don't know.
Yeah, Wesley. Yeah.
Ross.
I'm gonna go. I'm gonna go. I'm gonna go.
Me.
I'm gonna go.
No. All right. So, who has an answer that wants to?
I don't know how to walk you through it. I just know how to do it.
Okay, Isaac.
I know the answer.
Just stop talking. Juju, walk me through it. What did you combine? How did you get an answer?
So I combine 14x to the power of 2 and 2x to the power of 2.
Yep.
And you get, or negative 2x to the power of 2. And you get 12x to the power of 2.
That's correct.
You also combine 2x plus 6x, and you get 8x, and then there's just the 12. And then you divide them all by 4.
Good job.
And now you have new equations. 3x to the power of 2 plus 2x plus 3. And then you put those in parentheses, and then you put 4 on the outside.
That is correct.
Oh, so you did actual with
All right. So, remember what I want to really point out is when you have x squared and x, those are not like terms. You can't combine those. You have to keep them separate. So, what is circled in green is the correct answer. How exciting! All right. So. Your homework is going to be the worksheet on the back of your note packet. You can turn it in either today or with the note packet at the end of the lesson. It's just factorization. It's pretty easy.